Hey guys, so today I'm going to be going over a complicated differential equation problem where you get a non-elementary integral. Okay, so with that, let's take a look at it. So we have the derivative of y with respect to x is equal to y e to the power negative x squared. Let's say for the point y, 5 equals 1. Okay? And so let's say the question says to find an explicit solution for this initial value problem. So what that's really saying is that we have a differential equation on this side. And remember, a differential equation is when we have an unknown function like y, where we don't know what it is, a known function like this e to the power of negative x squared, and the derivative of that unknown function. And then in addition to that, we also have our initial value problem over here, which gives us the point 5 and 1. And what I mean by that is that this isn't your standard function notation here. What this is actually saying, and I'll just undo some of my markups here, is that this is for the function y of x. This is your x value, and then this is your y value. And sometimes people put y naught and x naught on these just to show that they are values. So these are actually values of this equation. And so with that, let's get started with how to actually solve this algebraically. So when you have a differential as normal, you're going to want to separate the x variables onto one side and the y variables onto another side. So let's do that by dividing by y and multiplying by dx. And so that's going to give us this. And then what we're going to do is we're going to integrate both sides to get rid of these dy's and dx's, hopefully. And at this stage, you're probably going to try, like I did the first time I saw this, to solve this integral here. But this is what's called a non-elementary integral. So a non-elementary integral, which essentially means that it's just very difficult to solve. And so we're not going to try and solve it because we don't have the mathematical tool set to solve it, but what we're going to do is try to get to as close as solving it as we can. And so when you think about that, how are we going to get closer to solving it without actually solving it? It seems kind of paradoxical. And one way that we can do that is by establishing some bounds on our integral, because that will allow us to get rid of the constants that we get when we integrate without bounds, and that'll get us closer to an actual value. And so when we think about how we want to do that, remember that we were given these original values up here. And so we can use those values as our bounds. So why don't we, on this side, start with the left side first? So the y value that we know is 1. So we know that the solution is going to be 1, and that it's going to be from 1 to some other y value. So we can put y up there. And then over here, we know that our x value is 5, and that it's going to be from 5 to another x value. Now, when you look at this, it's kind of weird, because consider what this is actually saying. What this is actually saying is, if we looked at it somewhat graphically, I'll draw a straighter line there, that we would have some type of function, right? Say it looks like that. And for our x side, we're evaluating the integral. Let's say this is 5 from 5 to another value x. And so as we're going from 5 to x, at the same time, our function is also changing. So when we actually get to x, we're going to have a different value there. So it's just kind of weird notation to have both our x in the integral and our x in the function. So what we're going to do is replace that with a dummy variable. And what I mean by dummy variable is just a little substitution. And so on this side, why don't we use t as a dummy variable? You can use any letter that you like. And another variable that we can use on the other side is u. So what I'm going to do is just simply replace those so that our notation is correct. And sometimes people will write this notation without the dummy variables, in which case it can just be confusing to who's ever reading it, because like I said, if you actually consider what's going on in math, you're approaching an x value, but then your function is also changing as you approach that x value. And so what we now need to consider is if we can evaluate this any further. And as I said, on the right side, this is non-elementary, but on the left side, we do know what the integral of 1 over u is. We know that the integral of 1 over u is going to be ln u, and then we have some bounds, so we can evaluate for those bounds. And then that is still going to be equal to our non-elementary right side, which is 5 to x for e of negative t squared dt. And so what we then can do on this side, of course, is further break that up using the fundamental theorem of calculus of ln the absolute value of y minus ln of 1. And that is still equal to our non-elementary integral on this side. And so looking at this, you should know that the value of ln 1 is simply 0, so we can cancel this out. And then when we were asked the question, we were originally asked to find an explicit solution. And an explicit solution means that we're solving for y. So we need to rearrange for this y here. And so if we want to get this out of our ln form, we can raise this side to the power of e, which is just ln y now, because this side went to 0, which I will clarify here. And then on the right-hand side, we are going to have e with our integral, our non-elementary integral, in the exponent. And I'm just going to clear up the board a little bit so that we have some more room to write. Okay, great. So now that we have some more room to write, I'm just going to continue this. So now we have our absolute value of y, because e to the ln of a function or a variable or a constant is just going to return that variable, constant, or function. And so then we have the absolute value of y equals e to the power, I'll make that integral sign a bit better, 5x e to the negative t squared dt. And so we have our absolute value here, but remember that our initial point was actually for the point 1 to 1, but remember that our initial point was actually for 1 to y, and so what we can say is that we know that y naught was equal to 1 from our initial value, and because 1 is of course greater than 0, this absolute value is kind of irrelevant because we're always going to have a value greater than 0 if our value is already 1. So we can say that y is equal to the e with the non-elementary integral 5e, 5 to the x, 5 integrated to x, e to the negative t squared dt. And that is our final solution. So hopefully this helped you, and thanks.